Okay, so this is the worksheet for section 1.2, part 2, and that's one where we're going to start solving linear equations and rational equations. All these four problems are considered rational equations. Remember, rational equation is an equation that has at least one rational expression. One rational expression, at least one of them. So this has at least one rational expression. This in particular is called a linear equation because it can be written in the form ax plus b equal 0. So it can be written in that form. So some number times x plus some constant equals 0. At some point you can write it. You can write in that form. This right here. And also note that the exponents of the variables are all being raised to the first power. Now, in particular, though, the rest of these are not linear equations. Even though you may say, well, all the variables are being raised to the first power, the problem is that in a linear equation, the variable cannot appear in the denominator. So in the rest of these problems, notice the variables located in the denominator. But they are all considered rational equations, and what we're going to do is solve these rational equations. Okay, so to solve a rational equation, remember the best approach, and there's several approaches, but the best approach is to multiply both sides by the LCD. So that way you can clear the fractions. And at some point you're going to want all of these to be ones. 1, 1, 1. So you want to clear those fractions. The same thing here. You want to clear these fractions and so on. Okay? So number one's easy though than the others because there are no variables. So basically all you got to do is find the LCD of 5, 2, and 5. Now see this one here? That's considered 1 over 1. So you can think of this denominator as 1 also. But the smallest number that 5, 2, and 5 can go into evenly is 10. So the LCD is equal to 10. And so what you're going to do is multiply both sides by 10. Now remember the approach. Remember it says show work as presented in class or the videos. So the approach is to multiply every fraction by 10, and that will clear your denominators. So if you notice, the left side here has two fractions in it, and the right side has two fractions. So what we're going to do is we're going to enclose those in parentheses, both sides. So we're going to say 7x divided by 5 minus x plus 1 divided by 2 equal, and then leave a little space here, and then 1 plus x plus 4 divided by 5. All right, so I've enclosed both of those in parentheses. Now what I'm going to do next is I'm going to multiply both sides by 10. So multiply this by 10 and this by 10. All right, so what you do one side, you do the other. Remember, the whole purpose of multiplying by 10 is so that when you distribute the 10 and you reduce, this 5 will end up being a 1. In this place, you'll end up having a factor of 1 and so on. All right, so the next step is to distribute the 10. Now, you may want to actually write in the step and not try and do so much in your head with these. So you're going to say 10 times this first fraction. Now remember, the common mistake people make is they reduce first. They'll say 5 and a 5 is 1, 5 and a 10 is 2, and then distribute the 2. That's incorrect because you're not going to multiply this by 2. You have to multiply this right here by 10. All right, so don't reduce first. You need to distribute first. So you're going to say 10 times 7x divided by 5 minus 10 times x plus 1 divided by 2. And since this, so you see how this is a monomial right here, and this is not a monomial, that's a binomial, it's a good idea to actually put that numerator in parentheses. So actually put this. All right, put that in parentheses. Okay, it's equal to, and then you're going to distribute the 10 here, so you can say 10 times 1 plus 10 times x plus 4 over 5, and again, put that in parentheses. And you're going to see why in a little while you want to put those in parentheses. Okay, now let's reduce. So when you reduce, you're going to say 5 and a 5 is 1. Remember, that's what you wanted when you multiply all these fractions. Notice I'm multiplying all these fractions by 10 times 10 times 10 times 10 times 10. So when I reduce, and the purpose of that is to clear those fractions, to clear those denominators. You want ones in their places. And now you'll see that we're going to get ones. Because 5 divided by 5 is 1, 5 divided into 10 is 2, and then 7 times 2 times 7x is 14x. Minus. Well, let's not put the minus just yet. Let's think about this. So here I'm going to distribute the, well, I'm going to reduce first. So 2 into 2 is 1. 2 into 10 is 5. Now, think about what's about to happen. So I am going to distribute a negative 5 through here. So both of these have to be multiplied by negative 5. So if you make a mistake and not put the parentheses here, it looks like I'm only multiplying x by negative 5, and that's incorrect. So this is not going to be negative 5x plus 1. It has to be negative 5x, and then negative 5 times 1 is a negative 5. So you got to be careful. So negative 5x, negative 5 times x is negative 5x, and negative 5 times a positive 1 is a negative 5. Equal. 10 times 1 is 10. And then over here, we're going to reduce also. So 5 into 5 is 1. 5 into 10 is 2. And again, I'm going to distribute a positive 2. So if you don't put parentheses here, you're only going to multiply the x by 2 and forget about the 4. So everything in here has to be multiplied by this positive 2. So I get 2 times x is 2x, and then 2 times 4 is 8. So at some point, you have to have this linear equation. So with no fractions, that's what you're supposed to have at some point. I need to see this. That needs to be shown at some point. Okay, now we're going to combine like terms. 14x minus 5x is 9x minus 5 equal. Over here, when I combine like terms, I can combine the 10 and the 8. So that's 2x plus 18. All right, now this is the linear equation. So you bring all verbs on one side, constant to the other. So I'm going to subtract 2x from both sides. And so I get 9x minus 2x is 7x equal. Minus 5 rather, sorry. 7x minus 5 equal. And then when I combine these two, that's 0. 2x minus 2x is 0. And 0 plus 18 is 18. Adding 5 to both sides. And combine like terms. I'm going to get 7x equal 18 plus 5 is 23. And then to get x by itself, right now I am multiplying by 7. The opposite is to divide by 7. 7 divided by 7 is 1. 1 times x is x. So I get x to be 23 divided by 7. And so that's your solution. 23 divided by 7. Okay. All right, number 2. And now number 2, we have variables in the denominator. But notice that all these denominators are monomials. And so it is easy to determine what the LCD is, and it's also easy to determine what your restrictions are. So whenever you have variables in the denominator and you're solving an equation, you need to indicate what your restrictions are, because you need to determine if that is going to be a solution or not. All right, so remember, you can never divide by 0, so you need to determine what makes this 0. What makes this denominator 0? What makes this denominator 0? And you can actually determine that in just looking at it. 2 times what number is 0? Well, 2 times 0 is 0. What makes this 0? Well, 0 makes this 0. What makes this 0? Well, 3 times 0, so x has to be 0, makes this 0. All right, so basically all you need to do is just set each denominator equal to 0. Set each denominator equal to 0. So when basically you're saying this, when 2x equals 0, then solving for x equals 0. Here, x equals 0. Here, 3x equals 0, so that means x has to be 0. So notice in all situations, x is 0. So there's only one restriction. You cannot have 0 in your denominator. I'm sorry, you cannot have x being 0, because when x is 0, that makes my denominator 0. Okay, so what that means is this. If I solve this equation and I actually get x equals 0, that happens to be a restriction, and so I can't use it, so you say no solution. Okay, so let's see what we get. So the LCD here is going to be notice that in terms of coefficients 2, 1, and 3, so the LCD of 2, 1, and 3 is 6. If you look at your other factor x appears in all denominators to the first power. So I just need an x, factor of x. So the LCD is 6x. Okay, so just like I did this one, I'm going to multiply both sides by 6x, and that will clear those denominators. So when I do that, the left side has two fractions in it. So I'm going to put that in parentheses. So 9 divided by 2x minus 3 divided by x equals, and since that's just one fraction, leave it alone. I'm not going to put in parentheses. Alright, but I am going to have to multiply both sides by 6x. So times 6x times 6x. Now just like I did this, I'm going to distribute. So you can distribute first before you reduce. So distribute first. So in the distribute, I'm going to get 6x times 9 divided by 2x minus 6x times 3 divided by x equals 6x times 5 divided by 3x. So notice every fraction is being multiplied by 6x. Now we're going to reduce. X and x is 1, x and x is 1, so the x's divide out. 2 into 2 is 1, 2 into 6 is 3, so notice I get 1's here. 3 times 1 times 9 is 27. Minus, over here, the x's divide out, and I get 6 times 1 times 3 is 18. Equal, over here, the x's divide out, get 1's in their place. 3 into 3 is 1, 3 into 6 is 2, 2 times 1 times 5 is 10. And then 27 minus 18, 27 minus 18 is 9. And 9 equal 10. Now, what happens here is that the variable is no longer present, so the variable disappears here. The variable disappears. So when the variable disappears, remember, you're either going to get no solution or you're going to get all real numbers, since we're dealing with rational equations that end up being linear. In this case, it's not an equation anymore, because this is not a true statement. So this is a false statement. So when the variable disappears, either you're going to get no solution or all real numbers for the most part. And you just determine that by looking at whether this last statement is true or false. So that's a false statement. 9 does not equal 10. So you just say, in this blank, you just say no solution. Or you can say the empty set. Alright, so that's number 2. Okay, the next one. Now, in this one, in number 2, the denominators were monomials. Here, that's no longer the case. So number 3, that's no longer the case. But you need to make sure that these denominators are factored. So x plus 5, I can't do anything with. I cannot factor that. The GCF is 1. X plus 5, the same thing. But the 2x minus 6, I can factor out a 2. So that's 2 times x minus 3. Alright, so let's find the restrictions first. So the restriction is I got to look at each denominator and determine what makes it 0. So for the most part, you can look at these and determine what makes those 0. So x plus 5, if you can't figure it out in your head, you just write it out. X plus 5, what makes that 0? Set it equals 0. And then you solve this linear equation. So subtract 5 from both sides. It turns out that x equals negative 5. So negative 5 makes this 0. And you can see it. Negative 5 plus 5 is 0. So one of my restrictions is negative 5. I can't use negative 5. Okay, let's go to the next factor. Now that's a 2. That's never going to be 0. But this factor here, x minus 3, can be 0. And the question is, when is it 0? When is x minus 3 equal to 0? Well, x minus 3 is equal to 0, you solve for x, when x is 0 plus 3 is 3. So my other restriction is 3. And then here, this denominator, this factor is already x plus 5. I already used it. So we're done. So I only have 2 restrictions. Okay, now let's find the LCD. So remember the LCD must include every factor you see. So one of my factors is x plus 5, so I have to use it. My other factor is 2, so I've got to use it. So, but always put the monomial factors in front. My next factor I see is x minus 3. There's none here, 1 here, none here, so I must use one of them. My next factor is x plus 5. I've already used it. Alright, so there's the LCD. So the LCD is 2 times x plus 5 times x minus 3. Okay, so then the next step is to multiply both sides by this LCD. Now, since the left side already is just one fraction, I'm just going to go ahead and rewrite it. And I'm going to multiply by, well, I'm just going to go ahead and rewrite it. The other one, I'm going to some space here, has two fractions, so I'm going to put that in parentheses. It's a good idea to instead of writing as 2x minus 6, write it in factored form. So 2 times x minus 3. And then minus 5 divided by x plus 5. And those two fractions, this side, so I'm multiplying both sides by the LCD. So you're going to say 2 times x plus 5 times x minus 3. And then over here, 2 times x plus 5 times x minus 3. Alright, so multiply both sides of this equation by the LCD. And I put this side in parentheses because there's more than one fraction. And also remember, you want to, if you can factor the denominators, you want to leave them in factored form. Okay, now we're going to distribute. And for room purposes, since I'm not going to have enough room, I'm going to go ahead and reduce this part first. So when I reduce this part, the x plus 5 and the x plus 5 here divide out. And so notice what you get though. You get 2 times 4 times 1 times x minus 3. So 2 times 1 is 2. 2 times this 4 is 8. So I'm going to end up with 8 times x minus 3. So it's very important that you had this, that you see that this is this. Equal. Okay, now I'm going to distribute. So I'm saying 2 times x plus 5 times x minus 3 times the first fraction, 2 times 3 divided by 2 times x minus 3, minus, and then the LCD, 2 times x plus 5 times x minus 3 times the second fraction. Okay, now just like we reduced this, we're going to go ahead and reduce these two parts here. So 2 into 2 is 1, 2 into 2 is 1. X minus 3 into x minus 3 is 1, x minus 3 into x minus 3 is 1. And so I'm left with 1 times 3 is 3 times x plus 5. So what I have so far is this. I have 8 times x minus 3 equals 3 times x plus 5. And so notice, and remember the whole purpose of multiplying by the LCD is to clear the fractions. So notice I have 1's in this denominator, I have 1's in this denominator. And then do the same thing here. X plus 5 into x plus 5. And so I get 2 times 1 times 5 is 10 times this x minus 3. So I get minus 10 times x minus 3. And so that's the equation you should have at this point. You need to show this equation. And now we're going to distribute. So notice I no longer have these denominators. So now it's going to make things a little bit easier for us. We just need to distribute 3 times. And so I get 8 times x is 8x. 8 times a negative 3 is a negative 24 equal 3 times x is 3x. 3 times 5 is 15. And then you're going to distribute the negative 10. Negative 10 times x is negative 10x. Negative 10 times a negative 3 is a positive 30. Combining like terms, I get 8x minus 24 equal. Alright, over here, 3x and a negative 10x is a negative 7x. 15 and a positive 30 is a positive 45. Alright, now adding 7x to both sides. Adding 7x to both sides, I get 8x plus 7x is 15x minus 24 equal, these cancel out, that's 0, and equal to 45. Alright, now I get, let me go ahead and rewrite this over, 15x minus 24 equal 45. Adding 24 to both sides, combining like terms, I get 15x equal, that's going to be 69, and then dividing both sides by 15, I get x to be 69 divided by 15. So that's your solution. Now notice that's not a restriction. You always got to check your restrictions. This is not one of these, so that's your solution. Now again, that's assuming that I didn't make any errors here. All right, now you can always check your work, but see how this is a fraction? You have to go back to the original, and I'm not even going to worry about it because that's going to be very cumbersome to check this, to check and see if 69 divided by 15 is a solution. Okay, now let's number 4. Okay, so number 4, again, you have variables in the denominator, and this is not monomial, but I cannot factor it. This right here, the x plus 2, is not a monomial, but again, you want to check to see if you can factor it, and you cannot. But this one you can, because that's the difference of two squares. So you want to rewrite this as the difference of two squares. So that'll be x minus 2 times x plus 2. All right, now basically, let's find the restriction. So what can't x be? So what makes this denominator 0? What makes this denominator 0? What makes this denominator 0? So in your mind, what number subtract 2 is 0? So these you can actually do in your mind, because 2 minus 2 is 0. And if you didn't see this, then just go ahead and rewrite it. So x minus 2 equals 0. That's what you're asking yourself. Where is this equal to 0? Well, add 2 to both sides. X minus 2 is equal to 0 when x is 2. So I cannot use 2. Go to the next factor. The next factor is x minus 2. I've already used it. The next factor is x plus 2. When is x plus 2 equal to 0? Well, subtract 2 from both sides. X plus 2 is equal to 0 when x equals negative 2. So negative 2 is your other one. Go to the next factor. My next factor is in that third denominator. That's x plus 2, which I have already done. It's right here. So there are only two restrictions. Now we've got to find the LCD. So the LCD has to include every factor that you see. So you learned about that last semester. So x minus 2 is a factor here. There's one factor of x minus 2 here. There's only one here, and there's none here. So remember, you always use the one with the largest exponent. So that's a 1, that's a 1, so I use 1. Alright, now the next factor is x plus 2. There's none here, 1 here, 1 here, so I need one of them. So your LCD is x minus 2 times x plus 2. Now you're going to multiply both sides by that LCD, so you can clear those denominators. So the left side has two fractions in it, so put that in parentheses. I'm going to leave some steps here. Actually, some space. Let me go ahead and rewrite it now. So that's x minus 2 times x plus 2, so LCD times the first fraction, just like this, equal, and then leave some space here, so I'm going to, oops, that was, okay, put that in parentheses. I've got that two fractions here, so plus 6x divided by, and don't write it as x squared minus 4, write it as x minus 2 times x plus 2. So x minus 2, x plus 2. So this whole left side is being multiplied by the LCD. Equal. Now since this right here, the right side only has one fraction, I'm going to leave it alone. In other words, I'm not going to put in parentheses, but I do need to multiply by the LCD. So x minus 2 times x plus 2 times the first fraction, or times that fraction on the other side. So notice every fraction is going to be multiplied by the LCD. Okay, now we gotta distribute this one. So I'm going to get x minus 2 times x plus 2 times the first fraction plus the LCD, so you distribute x minus 2 times x plus 2 times the second fraction. Again, make sure that denominator is in factored form so you can see which factors need to be divided out. Equal, and over here I'm just going to go ahead and reduce at this point. So the x plus 2's divide out here, and you're left with 3 times 1 is 3 times x minus 2. So you're left with this, 3 times x minus 2. Alright, so now let's reduce these right here. Let's reduce what we can here. So over here, the x minus 2's divide out, and you're left with 2 times 1 is 2 times x plus 2. So you're left with 2 times x plus 2. Plus, over here, this factor, x minus 2, reduces into this factor. This factor divides out into this factor, and you're left with 1 times 6x, which is just 6x, equal, and then 3 times x minus 2. Alright, now notice I no longer have denominators. That was the whole point of multiplying by the LCDs, to clear those denominators. So I'm just going to go ahead and get rid of the parentheses. I'm going to distribute. I'm going to distribute. So 2 times x is 2x. 2 times 2 is 4, plus 6x, equal. 3 times x is 3x, and then 3 times negative 2 is a negative 6. Combining like terms, 2x plus 6x is 8x, plus 4, equal 3x minus 6. Alright, now remember this is linear, so you bring all variables to one side, constants to the other. So I'm going to subtract 3x from both sides. 8x minus 3x is 5x, plus 4, equal. That's 0. Minus 6 is negative 6. Subtracting 4 from both sides and combining like terms, 4 and negative 4 is 0. 5x plus 0 is 5x, equal negative 6 and a negative 4 is a negative 10. So I'm going to go ahead and rewrite this. Now remember, I'm trying to solve for x. So right now I'm multiplying x by 5. The opposite of multiplying by 5 is to divide by 5. Divide both sides by 5. 5 divided by 5 is 1. 1 times x is x, equal negative 10 divided by positive 5 is a negative 2. So this looks like it. So this proposed, these are your proposed solutions. Your book uses the word proposed. So those are your proposed solutions. So the question is it actually a solution? Well, go back and check your restrictions. So I'm saying a proposed solution is x equal negative 2, and this is the only proposed solution. Well, it turns out I cannot use it. It's a restriction, because what happens is here, right here, let's use this one. When I plug in negative 2 plus 2 is 0, and I can never divide by 0. So right away, it's not a solution. So you'd say x equal no solution. Or you can say the empty set. Just write the symbol for empty set. Okay, so that takes care of worksheet 2. Well, the worksheet in section 1.1, part 2.